Today's problem is frog jump. Difficulty is medium. Given an integer array, height, where height at I represents the height of the ith stair. A frog starts from the first stair and wants to reach the last stair. From any stair I, the frog has two options. It can either jump to the I plus 1th stair or the I plus 2th stair. Cost of a jump is the absolute difference in height between the two stairs. Absolute difference because even though these are being called stairs, it's not really, an increasing sequence of numbers necessarily. It's, you could have something like this where the heights go up and down, unlike a typical set of stairs. Okay, determine the minimum total cost for the frog to reach the last stair. So the frog starts at stair 0. Here's a couple of examples. The best option here for the frog is to jump from stair 0 to stair 1 and then stair 1 to stair 3. Total cost 20. Now this one, minimum cost is jump from 0 to 2 at a cost of 20 and then 2 to 4 at a cost of 10, and that is 30. Height size, let's see, height size. So the size of the height array is going to be somewhere between 1 and 10 to the 5th, 100,000 inclusive. Heights will be between 0 and 10 to the 4th, 10,000 inclusive. Expected complexities, time complexity, linear. Yeah, we just need one pass. Auxiliary space, O of 1. That's kind of interesting. Okay, topic tags, dynamic programming, arrays. Yes. Dynamic programming. So it's pretty obviously a dynamic programming problem where we're going to build up the optimal solution by successively finding optimal solutions to subproblems. The O of 1 is kind of interesting. It happens in dynamic programming problems. I mean, the obvious way to do this, well, it's a one-dimensional DP problem, meaning we have an array of, let's say, stairs, and then we'll build up a dynamic programming array. So the first two numbers, we know what the optimal solution for those is, and then based on that we can figure out what is the optimal cost to get to stair 2, stair 3, stair 4, etc., so on up to stair, how many can we have here? 100,000. Yeah. Okay. But it's also it's like a Fibonacci sequence. So you want the nth Fibonacci number. So fib at n is equal to fib n minus 1 plus fib n minus 2. You don't need to know all the previous numbers. You just need to know the two previous numbers, and that's the same thing here. We can solve this problem even if there's 100,000 stairs. At each step we only need to know the cost of getting to the two previous stairs. That also happens, not infrequently in 2D DP problems where you have a matrix. You don't always need the whole matrix. Sometimes you just need the previous row, so you can optimize your auxiliary space by just using a 1D array rather than the matrix. Okay, so this one. Let's see. Is there anything else we need to look at here? No, I don't think so. Okay, let's try and go through this. I'm going to move this over here. I'm going to move this over here. We've got a couple of what you might call edge cases. Let's say that n is the length of the height array, and it is consistent with the constraints that the height array could have a length of 1. And if it does have a length of 1, then there's no jumping at all. I mean, the first stair is the last stair, so we'll just return 0. It's also possible that the array would have a length of 2, in which case the answer is just the absolute value of height at 1 minus height at 0. So those are really the two things that we know. I mean, we know the cost of getting to, getting to the first stair because we're already on it. We know the cost of getting to the second stair. Maybe I'm not saying that right. Let's say we know the cost of getting to stair 0, and we know the cost of getting to stair 1. After that, we have to do some computations. So, you know what? I scooted that over too far, and now we can't see the full array. So, all right. So let's say we get past this and this, that the array has a length of greater than 2. So let's start initializing these variables. Okay, previous to, which is the cost previous to the previous cost, is going to be 0 when we start. This is really the cost of getting to stair 0, which we're already on. Okay, and then prev. Right? This would be the cost of getting to stair 1. Height 1 minus height 0. What is that? 20 minus 30, absolute value 10. Right? And then we have a current. Right? We initialize that to 0 for no particular reason other than Java is going to require that. We can't just say int current and then return current and set current conditionally. Now, you know and I know that there's no way to bypass this loop, but Java doesn't know that. So current has to be initialized to something. All right. So let's do this. I equals 2. Now we've got to figure out the cost, the optimal cost of getting to stair 0, 1, 2. All right, so I equals 2. Math min is, so which is better to get to stair 2? Is it better to jump from 0 to 2 or 0 to 1 to 2? All right, that's what we'll look at. Previous to is 0. Math, absolute value of height at 2 minus height at 0. 50 minus 30, that's 20. Okay? So if we just hop from stair 0 to stair 2, that is going to be a cost of 20. The other option is we'll take prev and absolute value of height at 2 minus height at 1. That would be right here, 50 minus 20, 30. So that's not good. So the best way to get to stair 2 is just to hop directly from stair 0. Okay? So that makes our current 20. Right now we'll do some adjustments. We'll scoot the numbers down. Previous to equals previous. Previous equals current. And we'll go to the next index. And I should probably erase this because it's confusing. All right. Now, what's the best way to get to stair 3? Well, one possibility is go to stair 1 and then stair 3. So that would be previous to 10 plus absolute value of height at 3, which is 10, minus height at 1, which is 20. So that's 10. 10 plus 10. If we go to 1 and then to 3, cost is 20. All right. What if we go to 2 and then 3? We have previous, which is 20, plus height at 3 minus height at 2. That's big. 10 minus that's 40. It's too big. That's not going to work. So our best option again is going to be 20. Current will be set to 20. Previous 2 will be set to previous. Okay, good. Previous will be set to current. It's already 20. And what does that tell us? That the best way to get to stair 4 is go from 0 to not stair 4, stair 3, from 0 to 1 and then 1 to 3. Cost of 20. All right. Erase that. And finally, we are at stair 4. What's the best way to get there? One way is previous 2, which is to get to stair 2, and then we've got height at 4, which is 40, minus height at 2, which is 50. 40 minus 50, absolute value is 10. So previous 2, 20 plus 10, right? That is 30. What did we just do there? So we started 0, we jumped to 2, and then we jumped to 4. So that's 30. Okay. What's the other option? The other option is previous plus height at 4, which is 40, minus height at 3. No, it's too big. It's too big. That's going to give us 50. So the best option is 30. And, we'll make these adjustments, but at this point, we're done, really, and we'll return current, which is 30. So, this is rated medium. I'd say it's on the low end of medium. It's a pretty basic dynamic programming problem. It's just kind of like, Fibonacci with a slight twist. You are going to be required to understand that if somebody gives you a problem like this and says, can you do it with constant auxiliary space, that even though it's a 1D DP problem, you don't need the whole array. You only need the previous 2 numbers, no matter how many heights there are. You can have, how many heights can you have again? 100,000? Yeah, but you only need 2 of them. All right, let's get rid of this and try to run it. Okay, good. So yeah, please feel free to give the video a like. You can subscribe to the channel as well, and we'll see you next time.